now we're going to talk about the different ways that atoms hook together to make a molecule. And there are three different ways. So you have the covalent bond, the ionic bond, and then the metallic bond. So let's begin with the ionic bond, which we just got through talking about when we were doing this thing here. So the classical one that is used for ionic bonds is salt, NaCl. Okay, so that if we're talking about the outer electrons for sodium, so the valence electrons for sodium, it is going to be in column 1, so it's going to have one outer electron, and so we could indicate that with the letter X. So that stands for its outer electron. And then sodium, though, is going to have 7 outer electrons. So let's use dots to represent it. So 1, 2, 3, 4, 5, 6, and then 7. So that sodium, when it loses this electron, so it wants to give away this electron, it is then going to be a positive ion because the electron was negative. So the absence of negativity is positivity. And it's going to give that negative electron to chlorine. And so now chlorine is going to be negatively charged. So that sodium now is like this. It doesn't have any outer electrons. And then chlorine over here is going to have now 8 outer electrons, so it's happy. And so the two of them are going to stick together because opposites attract. So that's an ionic bond. It has ions in it. So that's how you can remember. Now up at the top of the chart there, it shows an example of an ionic bond in terms of some money. So if money is transferred from one person to the other person, then that's an ionic bond. Now let's compare this though with water, H2O. So water is H2O, so that means that for every oxygen is going to have 2 hydrogens that goes with it. Water is sometimes called the Mickey Mouse molecule because of the way that these hydrogens stick out. Now we're not concerned with that. Well, not yet. So let's just be concerned about where do the electrons live. So hydrogen is going to have 1 electron. It's in column 1. So again, let's put an X to represent those electrons for the hydrogen. And then now for oxygen, okay, let's go back to our periodic table. Find oxygen O on the periodic table, and again count columns. What column is oxygen in? So oxygen is in column 6. So it's going to have 6 outer electrons. So we could say 1, 2, 3, 4, 5, and 6. And so what is the magic number for oxygen? It's going to be 8. So oxygen wants how many electrons? It's going to want to have 8 electrons. So it's going to say, there they are. But what about hydrogen? So hydrogen's magic number is 2. So hydrogen's going to see these 2 electrons and is going to say, I want them. And then this hydrogen over here is going to see these 2 electrons and it's going to say, I want them. But oxygen is going to say, oh no, you don't. So it's going to be a tug of war. Oxygen wants these 2 electrons and hydrogen wants the 2 electrons. Do you see how it's different than here? Here, sodium is completely satisfied with 0 electrons, and chlorine has its 8. This time, this oxygen wants the 8, this one wants the 2, and it's going to be a tug of war on the electrons. So if you look back at this picture here, you notice that the whatever that denomination is, they are both holding on to it. And the fact that they're both holding on to that dollar is connecting them. So that is a covalent bond with water. Okay, then you can also have what's referred to as a metallic bond, which most often occurs with metals. All right, and so let's say that these are iron nucleuses. So these are the protons and the neutrons inside of different atoms of iron. Now we're talking about trillions and trillions and trillions of atoms. So just even in a typical teaspoon, you're going to have trillions of atoms in there. Now let's say that each one of these iron atoms is going to have 2 valence electrons. So this one's got 2 valence electrons around it, this one's got 2 valence electrons, and this one's got 2 valence electrons. Now the thing about the metallic bond is that these 2 electrons can go anywhere that they want inside the substance. And then these 2 electrons over here can go anywhere that they want in here. So you have trillions and trillions of electrons that are being shared. Now here is sharing up here, but this is the sharing of only 2 electrons. This is the sharing of trillions and trillions of electrons. Metals are good, what? Conductors of electricity. Can you see why? So the electrons are free to go anywhere that they want in this piece of metal, so metals are very good conductors of electricity. What do you think about water? So do you think that it conducts electricity very well? Actually not. So the electrons are held in place here, and they're not free to jump from one water molecule to the next. And the same thing for this one here. So not as good of an electrical conductor as what a metal is. So make sure that you know what is a ionic bond, what's a covalent bond, and what's a metallic bond. Okay, now the next thing that we're going to talk about in our next segment is we have already shown how to make a molecule. So the next thing is, if you got a molecule and a molecule, how can we fit them together, and what's the forces that are going to hold them together? So that's what we're going to talk about next.